Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Anuradha Kunte, Yeralavani Community Radio, Sangli, Maharashtra.
Hello everybody, you are listening to STEM Popularization Podcast. We all know that heart is very important organ in our body. The complete body function is based on how healthy your heart is, to provide continuous blood supply to the other body parts. And what if it stops functioning? Oh, it's even painful to just imagine. So while development of heart, there shouldn't be any defect, isn't it? You know, our scientists are conducting studies on heart and its diseases. Today in this podcast, we would like to introduce you with scientist Dr. Chinmay Patra. Dr. Chinmay Patra ji working in Agarkar Research Institute, Pune since 2014. Being a pharmacist as a profession, he completed his PhD in Germany in cardiovascular biology to know how heart is developed and mainly on congenital diseases. That is the disorders developed while formation of this organ. He conducted his studies focusing on two modules, mammalies and zebrafish. Let's get insights on his study of mechanism involved in heart regeneration in zebrafish from Dr. Chinmay Patra.
I got training to work on heart or cardiovascular biology. So how heart developed and different diseases, which you call basically congenital diseases, means this disease because of the malformation of the particular organ. Like I think you know about the valve defects. So this basically happened during the development of valve in the heart. So yeah, during my PhD work, I was trying to understand which genes or molecule is important for the valve development in mammalian system as well as tiny fish it called zebrafish. So it's both the model I worked during that time. Being a pharmacist, I was fascinated to work on basically mammalian system. That is, we do believe more closer to human, definitely. So I got interested in zebrafish at that time because in that tiny fish, this is basically from India, I would say, and they are rice filled, and also in river Ganga and other rivers throughout the country you can see those. But they are very popular hundreds of years because it was ornamental fish traveling throughout the globe. So 1960 and 70 in USA, one scientist basically he showed that that one can use that fish as a model system because you can get a lot of animals or eggs from a pair of zebrafish, male and female, and their fertilization happened outside because that's why you can see how from a single egg one complete animal develops. So this is one beautiful thing, so one can study it. So during my PhD study also I saw that how heart is functioning. So blood cells or how it is moving from one chamber to another chamber in the heart, how it is circulating throughout the body, one can really see it. So that's why that we thought that maybe that this model will be wonderful to do it. And that is one part. And second part is if you look at the genetic control, that is pretty similar between human and also zebrafish. Around 70% genome structure is similar. So that means also particular functions or how that development is happening that can be studied in that tiny animal and then extrapolate to human. So this is one beautiful thing. At that time I basically looked at the valve development, how heart valve developed. and which are the different molecules are involved in it. So this is during my PhD and also postdoctoral work. But after coming back here, I showed interest to work on heart regeneration. And that was my actually dream during my, study when I have done my master's degree and bachelor degree. So I thought I should work on the heart regeneration. The main reason is that we all of us know that, in human, if there is 3 major heart attacks, after third attack, nobody can survive. The reason is that every attack, around 20 to 25% heart get damaged. So muscle get damaged basically. And we can't really replace this damaged tissue. For liver, we can regenerate. In the skin, we can cut and get regeneration. But in case of the heart, if this one attack happens, then one part of, as I told, 25 to 30% damaged muscle cannot get back. So basically, function of heart goes down. Then doctor said, take rest and all these things because heart is not good enough as it was before. So if you imagine 25%, 3 times means 75% muscles gone, means there is no chance that heart can pump the blood throughout the body. So that's why basically this is the case. So human can't do it. However, we have many studies show that we have very limited capacity of regeneration. The regeneration in the sense, basically during the healthy lifestyle or healthy life where heart is not damaged, some part cells of get replaced with the new cell. So that means we have very limited. But when self-injury, not. But in case of this tiny fish, it's just like 1 inch long, this zebrafish, they can regenerate their heart. If you make injury in the heart, similar like our heart cardiac injury due to the heart attack or myocardial infarction, within 3 months they can completely regenerate their heart and it is fully functional heart. So my group at Agarkar Research Institute actually trying to understand how they can do it. So if you want to develop any drug or anything to induce heart regeneration in human, we need to know how it is happening. So we are trying to know that which protein or the receptor which are involved in this business, so that we can extrapolate to human heart regeneration issue. So I do mostly work on zebrafish, but whenever need, we also collaborate with the people who are working on the animal models. That is the future. Moving from this fish to then maybe mouse and then so on.
You are listening to STEM Popularization Podcast. We heard about the study of Dr. Chinmay Patra ji. He explained well on his study of zebrafish module to know heart formation and its diseases. Now he will be explaining about the study further towards possibility of heart regeneration or other way of handling heart issues in context of other researches going on globally. Let us know more about his involvement in research on the regeneration of disc residing in the bones of spinal cord. So basically related to the pain in the back. So we are going to hear from Dr. Chinmay Patra ji about his publications and the further research on heart and the disc of backbone.
So if you talk about the heart regeneration or any cardiovascular disease, India is very few people or very few labs working on the cardiovascular biology. So if you particularly think about or speak about regeneration, then I think we are the only one who are really looking into the regeneration in the aspect of, we use the fish and then how it is happening in this case. So that we are looking on that. But in fact, overall cardiovascular disease, very few people. So we mostly, heart regeneration, but also other organ regeneration. We are looking at the model system where people can do the drug screening even. So nowadays it's very popular drug screening, so personalized medicine. So we are also developing disease model. So if we know that, because of this genetic problem, one child born having this kind of issue, so one can make the zebrafish model of the same kind of. So having same problem, and we can screen the drugs, like you have maybe 10,000 or 15,000, whatever it is. Those are FDA approved molecule, so we can screen and we can find that maybe that is helpful for certain particular disease. So it will be like personalized medicine kind of. We are also developing some disease model. We have already developed 2 models and we applied for funds that we can now start this thing. Globally, of course, we are collaborating with the people that who are working on the heart regeneration, like Western countries, Germany and also US. So I think that in India we should have more group that will working on this, the field that will help us to go faster forward. I would not say that we are really competing, but that a group like a few group I can say that in IISc Bangalore, Sundaresan, so he is working on the cardiovascular diseases, and also in STEM, Dr. Perundarai, so he is trying to understand also cardiomyopathy-like diseases using human iPSCs. These things are doing, but I'm really not competing with them. I would say we have started little late if you speak about the globally. But if I talk about the cardiovascular, it also now I think much, number of groups are much higher than the earlier. With the standard of the work we are doing in India in all the different groups, I think it's global standard. So as I mentioned that, the heart regeneration basically does not occur. So the main problem, if you think about all the research we are doing, the main problem is that how we can't regenerate our heart, and there is no medicine, no surgical or, medicine-based procedures available to promote heart regeneration or come back to the normal healthy situation. That is not there. So only thing is that heart replacement. And of course the donor is much, much less than the what number of, the people are waiting for the heart transplantation. So definitely we need to find something that to promote the heart regeneration. So what do we believe that, what we are trying to find out that the process of heart regeneration using or natural process of heart regeneration that happening in other animals. So one day probably we'll find targets, one or more targets to promote heart regeneration. Definitely it will be beautiful for all, everybody for the globe. We are basically not focusing only the heart regeneration. So many times when we do the research, we have some hypothesis, but outcome many times comes some interesting thing that we did not think about before. So my lab, we recently found a molecule or the protein that which can promote disc regeneration, like the intervertebral disc. All of us, we can think about our back pain. So it's because of the intervertebral disc regeneration. So again, for the same thing that we don't have any medicine that which can improve the disc. So if you think about the intervertebral disc or the disc, that basically is like cushion, and it resides between bones in the backbone on the spine, where we have many spines and in between, and it's give the frictionless movement wherever we bend, walk or body posture different, but that give the flexibility and it does not press each other, so there's no pain. But you will wonder that this degeneration of the disc means thinning of the disc start as early as 13 to 14 years of our age in human. So it starts the degeneration, and there is no way to get back or to the regenerated disc. So only we take pills to suppress the pain or the operation, surgical procedures. So what we found that in case of this tiny fish and the zebrafish, they do also go through the degeneration. So they also have the scoliosis, like the curved body structure when they are becoming 3 years old. So for them 3 years means pretty old there. So they have the similar thing. We found the protein, if we give extra amount of it, we can get back to the normal. So that is our new finding. So we are also working on, intervertebral disc regeneration. We published well-reputed journal like Science and also Development. So that is a very reputed journal, and also into chemistry journal. Those are in collaboration with TIFF, Dr. Patra's lab.
On behalf of all the listeners of STEM popularization, I would like to thank you, Dr. Chinmay Patra ji. Thank you very much.
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Anuradha Kunte, Yeralawani Community Radio, Sangli, Maharashtra.
आपकी आवाज